Every day, the outside environment is constantly changing. For example, today it might be sunny, or tomorrow it might be cloudy. But your body still has to maintain an internal temperature of 37 degrees Celsius or 98.6 degrees Fahrenheit, no matter what the weather is. Similarly, today you might eat a hamburger, tomorrow you might eat a salad, but your body has to stay relatively stable inside and get nutrients from the food you eat. This concept is called homeostasis. It's the ability of the body to maintain relatively stable internal conditions despite constantly changing external conditions. Note that this does not mean that you are not changing. The body is constantly in a dynamic state. In fact, if you do not change, then you're basically dead. Let's take a closer look at homeostasis with some examples. Let's take the sun as the stimulus. Now, what might happen if you're out in the sun? Your response could possibly be sweating. Why? Well, if you get too hot, remember you need to maintain a stable internal temperature, so you might sweat to cool off. Homeostasis is maintained mainly by negative feedback loops. So for example, if your temperature is okay, but you go in the sun and you start to get too hot, then you might sweat to cool off. Notice the original change was being too hot, and the response was to cool off, which stops the original change. In other words, it negates the original change, and that's why this is called a negative feedback loop. Be careful, negative is not a bad thing. It's just called negative because it negates the original change or opposes the original change. So the negative feedback loop creates a change in the opposite direction from the original change. In this case, the original change being too hot, and then the opposite change was to cool off, which stops the original change. This is similar to perhaps the thermostat in an apartment or a house. For example, if a room gets too hot, the thermostat might sense that and turn on the air conditioner to cool it off. The negative feedback loop involves a process. Let's look into this in more detail. We have the stimulus, in this case, the sun, and it caused a change, X, in this case, too hot. Now, in your body, a sensor needs to sense that change. In this case, sensing that it's too hot will occur in the brain. The brain will get the information, perhaps from thermoreceptors in your skin, that it's hot. And the sensor's job, in this case the brain, is to send that information to the integrating center. At the integrating center, the information is taken in and a decision needs to be made on what to do about it. So in this case, the integrating center is also in the brain. In fact, it's in an area called the hypothalamus, which we'll come upon again. It's the area that controls the temperature of your body. The integrating center takes in the information that is too hot and then decides how you're going to cool off. The integrating center sends the information to the effector. The effector will actually implement the effect that you want, in this case, to reverse the change. Now remember, the change here was it's too hot, and the result was you sweat to cool off. So the effector in this case would be your sweat gland. The sweat glands will actually cause the response you want, which is the sweat and cool off. Notice that the cooling off is opposite of the original change of being too hot. So that's why this is a negative feedback loop. The little negative sign here demonstrates that we are negating or going in the opposite direction of the original change, which was too hot. And this is a complete loop. So we just went through the example of the body being too hot and then going through the negative feedback loop to sweat to cool off. You can consider the opposite case. Let's say your body is too cold. So the original change is being too cold. Think about what your body might do in response. You could shiver to warm up, or in fact, you might get goosebumps on your skin to warm up. And you can think about how the negative feedback loop is executed in this scenario. And again, negative feedback loops is the main way that homeostasis is maintained in your body.